So here we will show how this reaction happens. What is the reaction? This is ethyl fluoride, and what happens? Br minus bromine nucleophile attacks to this alkyl halide, and how this reaction happens. So in this medium, that bracket, it represents transition state. What happens? The Br minus, that nucleophile attacks, and again it attacks at the same time the Cl reads, means both attack of Br minus and Cl removing happens simultaneously. Then Cl minus, it has a leaving group, it removes, and Br attached to the alkyl halide. Now it is chlorine removing and Br incoming. Okay. In the next slide we will see how this backside attack happens. In the backside attack, the nucleophile attacks the substrate from the backside in a single step, means it attacks from the backside, because this is the principle of sn2 reaction. Here we have taken another nucleophile, that is Cn minus. It attacks to the alkyl bromide group. This is the transition state in the medium, that is in the bracket. And what happens? It is S. So we have, as you have stated, the absolute state configuration S, and the product is R stadium mode. Okay. It explains bimolecular rate law, and explains inversion of stereochemistry, and explains the sensitive to stereokinase. Means this picture explains three things, that is bimolecular rate law, because both this is a rate determining step, or rate determining step. It determines rate of reaction, and it depends on two things, that is nucleophile incoming and the substrate. Okay. So it is inversion stereochemistry. As we have seen, it is S and the product is R. So this is called sn2 mechanism. sn2 means substitution nucleophile bimolecular. Okay. In the next slide we will see how this rate is affected by changing the substrate. Here it is secondary, it is primary, it is methyl, it is tertiary. You see, from secondary the rate is 1, primary it is 20, methyl it is 1000, but when you increase the alkyl group, it is tertiary, the rate, approximate rate is 0.001. means if the alkyl group becomes steric, becomes bulky, then that attack of incoming nuclei is hindered. That's why the rate decreases. Okay. In the next slide we will see rate law. As I have mentioned, the substitution reaction is sensitive to the concentration of both nucleophile and substrate. So here we have the substrate is alkyl bromide, and the nucleophile is cyanide, and a rate is increased by the substrate. It is directly proportional, as well as the nucleophile. It is directly proportional to the nucleophile. Okay. So in this short video I just describe how the rate is affected by substrate and nucleophile. So thank you.